Hello guys, welcome to my YouTube channel. I am going to show you database about students in level 6 IT. This is database of the main user and there is some purpose they have. The purpose of the database is to help students organize their academic life, providing centralized platform to store course information, recording assessment scores, track deadline, generate academic platform records. The main users of this database is the student academic advisor, system administrator. A student is a primary user who enter data and review academic progress, review student progress, and provide guidance. System administrator will manage and database user account. The system objective is to store and manage student professional and academic information, track courses taken each semester, record assignment details with weighting and deadlines, store submission score and feedback, and monitor performance over time. Second point is identification of database entity. Number one entity is student that store information about a student. There is some key attribute. Student ID will be a primary key. Name, email, major, and enrollment year. Second entity is semester. Instructor, course, enrollment, assignment, and submission that will help the student work their assignment on. Entity relationship. Third point is personalization to third normal form. Then as you see on this randomized uniform, there is something that was repeating group of assignment. There is a redundant student semester course and instructor data, insertion update, and duration to normalize. The first normal form, it will pass to remove fitting groups, creating separate row for each assignment, established a composite primary key, like a student, semester, course, and assignment. The second normal form, it will pass to remove partial dependencies and create a separation table for that attribute for that is some correction forms. On third normal form or table are there is no statistic dependence exists. Each non-key attribute depends on only the primary key. Here we are going to show the relationship between that entities from one to many, one to one. This is the handwriting hierarchy. That shows the entity and the relationship between the entity from one to many. From student have to be enrolled in enrollment entity. That is the some more things that have to be data dictionary. That data dictionary show the table of students, their data type, the constraint, and the description for every table. The table of semester, they have shown the semester ID, what data and in data. There is some more queries that we have been using to create the database. As you see here, we have using XAMPP, MySQL to create that table. There is 7 tables. There is some base you can like select from a student that help us to retrieve or record from single tables. There is page number 2, the count table record in the table. This is the SUM code that help us to select a total cost from one entities. That that select or account as total account from cost that will help us to measure all aggregates and calculate the sum. This is the query that help us to make a sum of something that was in the one tables of some quantities. They find the maximum and the minimum. This is the select max score as high score, minimum score as low cost from submission. Here we have using the table of submission to calculate the high and minimum score. Group recording and apply aggregation function. We have used that query that we use in assignment table that show us that help us to select the ID according to the number of the assignment. We have used the retrieve recorded between the filter range that we use a select all from submission between. So this help us to select and retrieve or record between the filter range as you see on this screen. There is query retrieval record using in and match the values. There is some drawing and as conclusion, the student academic progress tracking database successfully demonstrates all requirement components of the complex database solution. The summary of achievement, the real-world academic tracking scenario selected a 7-core entity described by justified step-by-step normalization to the third form completed clear errors SQL implemented with proper constraints, and this database provides the practical tools for students to track the academic progress of the university students. This design is scalable, can be extended to include the degree auditing, transcript generation, and integration of learning management systems. Do like, share, and comment.